Hey everyone, hope you're doing well today. In this video, let's go over 7 different practice problems dealing with ratios and proportions. All right, so let me just zoom in here and let's just focus on number 1 first. Given that triangle LMN is similar to triangle STU, we need to find the length of SU. Now keep in mind SU here is going to be the first and third letter of this triangle. So we have the first and third letter, that's SU. And so that's got to correspond with the first and third letter of LN, right? The two letters L and N. So those two must correspond with each other. So what we're going to do over here is I'm going to go ahead and write that ratio right away. So I know the ratio is going to be from this, I guess we can go from the longer one to the shorter one. That's perfectly fine. So I'm going to do 19.5 to X. Okay, so we're going from the bigger one to the smaller one. And let's see what else we have here. We also have ML, right? So ML is this length over here. So that's going to be M is the second one to the first one. So for the smaller triangle, we need to go from the second one to the first one, from T to S. So that's going to be this line right over here. So if we're going to go ahead and write that ratio, we're going to say that's going to be 24 over that 9.6. That would be this proportion here. Now, if you're solving these types of problems, there's many ways to go about solving these proportions and equivalent ratios, but for this video, I'm going to actually just go ahead and use cross products. Remember that if two ratios are equivalent to each other, if you multiply their cross products or the diagonals, we should get equivalent expressions. So 24 times x is just going to be 24x, and on the right side, 19.5 multiplied by the 9.6, that's going to equal 187.2. Okay, and then if you want to solve for x, then you can go ahead and use the division property of equality, divide both sides by 24. So this 187.2 divided by 24 means that x is going to equal 7.8. Okay, so the question says find the length of segment SU. So we can say segment SU is going to equal 7.8 meters. That's what that would be. Cool. Let's take a look at number 2 here. Okay, so we have this trapezoid here of ABCD. So trapezoid ABCD is similar to trapezoid PQRS, so everything is going to be proportional and has the same ratio. We need to find the length of PS here. So PS is what we're looking for. So let's see how we can go ahead and identify it. So PS, that's going to be located down here. That's over that X value. And PS, let's see, PS is going to be the first and the fourth letter. So that's going to correspond with the first and the fourth letter for A and D. So those need to go together. So this one's not too bad since they're already kind of in the same direction. But if they were flipped upside down and stuff, they could be a little bit more confusing. So just kind of good to identify using the order of the letters. This time I'll maybe go smaller to bigger. So I'll put SP first, or PS, whichever one you want to call it. That's going to be X. And that ratio of X to 52.8, let's see, we need to do a ratio between that and this QP because we know the length of QP. So Q and P, that's going to be the second and the first letter. That's going to correspond with B and A. So that's this one right over here. Okay, so I think I went X to 52.8, which is small to big. So I got to go small to big again, the ratio of 28.8. Let's do that to 38.4, okay? Now that we have a proportion, or we have a ratio equal to another ratio, we can go ahead and use cross products again here. So if we multiply the 38.4 by x, that's going to be 38.4x. And on the right side, if we take that 28.8 and then multiply that by the 52.8, that's going to end up being 1,520.64. And then we can use the division property of equality, divide both sides by 38.4, divide by 38.4. And if we divide that big number by 38.4, we should find out that x is equal to 39.6. But what is that really telling us? We were looking for PS, right? PS, we substituted in for the value of x. That's equal to 39.6. And I think we're talking about feet here. So those are our units that we should label it with. Alrighty, let's check out number 3. For number 3, it looks like we are looking at this rectangle EFGH, and it's similar to rectangle WXYZ, and we're looking for the length of XY. So where's XY located? Well, XY is located over here to the right. We're going to call that length X, so XY are the middle two letters here. So that's got to correspond with the middle two letters over here, which is going to be F and G. Okay, so F and G are up here, but we don't know the length of that, so just keep in mind that that is the same as the length down here of EH. Okay, so we know those are going to be the same. Let's go ahead and write a ratio for that over here to the right. So let's see, I'm going to go ahead and put number 3 right over here. For number 3, we know we have a ratio. I'm going to go from the rectangle to the right to the rectangle on the left. I just like having my X on top, but it's your preference. And we know that's going to correspond with FG, but remember, FG is the same as EH, so that's going to be 8.96, okay? Now, we went from the right rectangle to the left rectangle, so what else do we know from the right one? Well, we actually know that ZY is this 31.5, so Z and Y is the fourth and the third. That's got to correspond with the fourth and the third, so H and G. So that's got to correspond with this one right over here. So we went from right to left. Let's go from right to left again. So this is going to be 31.5 centimeters to 17.64 centimeters. Okay. So again, we're going from the right to left, and we're going to use cross products here to solve this. So 17.64x should equal the product of 31.5 multiplied by 8.96. And that's going to be 282.24. And we can go ahead and use the division property of equality and divide both sides by 17.64. Divide by 17.64. If we do that, it's actually going to come out to a nice number here. X is going to equal exactly 16. So we know that the length of XY, segment XY, is equal to 16 centimeters. Cool. Let's take a look at number 4 now. Looks like we have another trapezoid. We have trapezoid ABCD, and that is similar to trapezoid STUV, and we need to find the length of ST. Now, where's ST? ST is down here, and we're going to call that X, and ST happens to be the first two letters here, so that's got to correspond with A and B. So AB is up here. So even though it's flipped upside down, keep in mind which ones go with each other in terms of what corresponds with which. So that's the longer side of the parallel line of the trapezoid. Okay, so maybe I'll go from the trapezoid to the right to the trapezoid on the left. I think it's the smaller to maybe the bigger one. So I'll do TS, which is X. And we said that corresponds with the 7.15, or 7 and 15 hundredths. Okay, so we have that part started off. That's the ratio of the right one to the left one. And what else do we know from the right one? We know the right one. We know UV. UV are the next two letters, or the third and fourth. That must correspond with C and D. So that's going to be right over here. So what we can do is go ahead and write a ratio of that. And that's going to be 2.28 inches to this 2.85 inches. So we're going from purple to purple, okay? So that's our proportion, and we can go ahead and use cross products here. So 2.85 multiplied by x is just 2.85x. And for the other cross products, that 2.28 multiplied by 7.15 is going to equal 16.302. And then we can go ahead and divide both sides by 2.85 and divide by 2.85. Those are going to cancel out on the left to make 1. So if I divide 16.302 divided by this 2.85, that's going to equal 5.72. So what was X representing? I think that was segment ST. So segment ST is equal to 5.72 inches. That's going to be the length of segment ST. Alrighty, so that's 4 problems down. Let's take a look at number 5 here. This one looks like it's a little bit more involved. It's got this interesting shape going on, this triangle, okay? And then so I'm going to go ahead and get more space over here to the right. Let's go ahead and put number 5 here. Okay, and then let's kind of give it a go. It says, in the figure triangle ABC, that's this one right here, triangle ABC, and triangle ADE, triangle ADE and triangle AFG are all similar to each other. Okay, so they're all proportional, same ratios. We need to go ahead and find the length of DE, and then FG, AE, and AG. Okay, so 4 things to do here. Now, before we get started, I just want to identify and show you where these triangles are. So triangle ABC is located right over here. That's the smaller triangle, okay? Then for triangle ADE, that's this one right over here. It's this medium looking triangle, okay? So that smaller one is proportional to this bigger one, and then AFG is this big triangle. So they're all similar to each other, all three of these triangles. All right, so now that we know where they are, let's go ahead and see if we can write some proportions to solve for these missing lengths. So for this first one, let's go ahead and try to find the segment DE here. So DE, let me go ahead and draw where DE is located. That one is right over here. We don't know what that is, so maybe I'll call that X for now. Okay, so what does that correspond with? Maybe I don't know the bigger one, so I'll go to the smaller one here. So I'm going to make a ratio from the length or the height of that triangle to the height of the triangle. So I'm going to say X is DE, right? So I'm going to say X to 12. I'm going to the medium triangle to the small triangle. And then if we do that, we have to do the ratio of maybe the medium to another medium. So what's the medium triangle's length across here? That is going to be 24 plus 16. So 24 plus 16, that's the medium length all the way across. We're going to do that ratio of the length across to this other triangle's length across, the smaller one, and that's just going to be 16. So again, we went from medium to small and medium to small, and we had to set up a ratio just like that. So simplifying this a bit here, we have X to 12, and on the right side, 24 plus 16 is going to be 40. So it's going to be 40 to 16. Okay. If you want to, you can simplify this a little bit. We don't need a calculator or to use cross products. I can divide this by 8 and divide this by 8. If we do that, we're going to get X to 12 is equal to 5 to 2. And I think if we multiply 2 times 6, that's going to be 12. So then 5 times 6 is going to be X. So X here is going to equal 30. And remember, what did X represent here? It really represented segment DE. So segment DE should be equal to 30 meters. There we go. All right, so I forgot to label this, but I'm just going to say that this was just part A for number 5. Number 5 has a few different parts here. All right, so part A is done. Let's go ahead and clear out some of these drawings so that we can kind of have some space here to do more work for the next parts. So for part B, what do we have to do? We have to find segment FG. So where is FG? Let me see if I can label that first. FG is this long one here. That's another height. We don't know what it is. I'm going to call that X for now. Okay, and we don't know, we could do it with DE, but let's pretend we don't know DE, because like what if we did it wrong? So maybe let's compare it to what we're given here, which is the short one. So let's go ahead and write the ratio of X to 12, except this time X is the length of the biggest triangle, or the height of the biggest triangle, right? So we're going the biggest to the smallest right now. And we need to set up another ratio here that has to go from biggest to smallest. So from biggest, that's all the way across here. So what's that going to say? That's going to be 4 plus the 24 plus the 16. That's all the way across. And we have to do that ratio of the all the way across just to the smallest one, which is going to be 16 here. From here to here, that's going to be 16. Okay, so we can simplify this a little bit here. We're going to get, if you do 4 plus 24 plus 16, I think that's going to be 44. And then that's going to be over 16. I think we can divide this by 4 and divide this by 4. So we'll get X to 12 is equal to 11 to 4. And then 4 multiplied by 3 will get you 12. So 11 multiplied by 3 should get you X. So I think X should be 33. And this time X was the length of FG, right? So segment FG should be equal to 33 meters. I think that's what we just found out. Alrighty, I think A and B are now done and correct. Let's go ahead and get rid of this, and let's keep on going here. So that was A and B. Let's try part C now, okay? So for part C, let's see what we got. We have to go ahead and find the length of AE. So where is AE? Interesting. AE is located over on this diagonal. So that's the hypotenuse of the medium triangle. I'm going to call that X here. And so we don't know the hypotenuse of the biggest triangle, so we can go ahead and set up a ratio between the medium triangle's hypotenuse and the smallest triangle's hypotenuse. So the smallest triangle is really helping us out a lot here in this problem because it has all the information we need. We know all three sides. And so I'll go from medium to small here. So medium's hypotenuse is x, and then the small triangle's hypotenuse is 20. Okay, and then so we need to do something else with medium to small. So what else do we know from the triangles? Well, the medium one, we don't know the height really, right? We're going to pretend we don't know it, even though we solved for it earlier. We could have made a mistake. So the medium triangle's length across the bottom is going to be 24 plus 16. So I'm going to write 24 plus 16. Again, that's the medium ones all the way across to the small one's base as well. So that's going to be 16. So simplifying this a bit, we can say x to 20 is equal to 40 to 16. Then we can go ahead and divide this by 8 if we want, divide this by 8. Again, this is a type of problem that you wouldn't really need a calculator for, and so this would be 5 and this would be 2. And then 2 times, whoopsies, this 2 times 10 would be 20, so 5 times 10 would be 50. So x here would be equal to 50, and in this case, x was the length of AE, right? So we can say segment AE is equal to 50 meters. Perfect. Alrighty, now that C is done, let's take a look at this last one for number 5, which is D. We need to find the length of AG, so I'm just going ahead and clear this out. And so where is AG? I think AG is this entire hypotenuse. That's AG. I'm going to call that X in this case. We know the medium one, but again, like, you know, if we made a mistake with it, we don't want to use that. So let's use what we're given here. So let's make a ratio between that and the smallest one here of AC. So let's go ahead and put a D here. And so I'm going to say AG, the longest hypotenuse. We'll do the ratio of the longest hypotenuse to the shortest hypotenuse. So in C, we did medium to small. Here we're going from large to small. And we need to go from large to small again, whatever we do for the other number. So I'll do large, I'll do large, which is I'll do the entire across the bottom. And then we'll do a ratio of that to, if we want large to small, we have to go large to small again here. So if we do all the way across the bottom, that's going to be 4 plus 24 plus 16. That's all the way across the bottom to just the small triangle's bottom, which is going to be 16. We can go ahead and simplify this a bit. That's going to be 44 over 16. I think we can simplify this by 4 and 4. So that's going to be x over 20 is equal to 11 over 4. Then 4 multiplied by 5 is 20. So 11 multiplied by 5 means that x is equal to 55. And in this case, x was AG, right? So segment AG is equal to 55 meters. All right, so number 5 had a bunch of parts, but hopefully I showed each of these steps a little bit more clearly, and you can imagine where all these pieces are. Make sure you set up ratios that go from like small to medium, small to big, and keep it consistent, or big to small, or medium to small. Whatever you do, you have to keep the ratios consistent and make sure you're keeping track of all your numbers. Okay, so that is D. Let's try the last 2 problems here. So for number 6, it says, given that triangle PQR is similar to triangle STU, tell whether the given information is enough to find the specified measurements. Explain your thinking. Okay, so for number 6 here, what we're going to do is I'm going to go ahead and draw these triangles so that we can see them more clearly. And so here is one of the triangles. I'll call this P, Q, and R. And we know it's going to be similar to another triangle. I'll make it a little smaller. You can make it bigger if you want to. And let's call that triangle STU. So we're going to use this drawing a few times here. Okay, so just copy and paste that. So for A, it says, segment PQ. So let's go ahead and mark that up. So PQ is located here. So if we knew PQ, and then if we knew PR is going to be down over here. And if we know this third side, which is going to be TU, I'm going to mark that on this triangle. The question is can we find out the length of ST given this information? And for this one, what we're going to do is we're going to say no, just because there are no corresponding side lengths that we have here. So if we had known maybe like if we had known that this ST and PQ were the same or were corresponding, we knew their measurements, then we could set up a ratio. Or if we knew that PR and SU, if we knew both of those measurements, we could have set up a ratio. And finally, if we knew QR, the hypotenuse, and TU, then we could have. But since none of them line up, we can't actually solve for segment ST. So we don't have enough information for this first one. Okay, so that's going to be 6, and that is going to be for part A. And for part B, we can take a look at this drawing one more time and see if we can figure out based on the information for this one. So if we know PQ is going to be located right over here. Okay, that's the height. And then they tell us we know QR, so QR is the hypotenuse. That's this one right over here. And they also tell us we know PR. PR is the bottom. So actually for this first triangle, we know all the 3 side lengths. That's good. And then ST. So ST is going to be the height over here. And since we actually have 2 that are matching here, or they're corresponding, we could set up a ratio. And if we had that ratio, then we could find SU, which is the one down over here. So for this one, we can actually set up a ratio, right? We could say that PQ to ST, because we would know those measurements, and then that would be equal to segment PR to SU. And so if we knew 3 out of the 4 of these, then the answer is going to be yes. We could find out the length of SU given this information. Okay. Last part for part C, it says you know measure of angle R. Let me go ahead and just draw this triangle, these triangles one more time. So if we knew the measurement of angle R, angle R would be located right here. The question is can you find the measure of angle U, which is going to be right over here. And again, this was just kind of a hypothetical drawing, so these triangles don't need to be drawn this way. They don't have to be a right triangle. I guess if they were, then these would be similar. But again, we could have also drawn these triangles a little bit differently. I could have said this was P, and this was Q, and this was R. And then we could have also said R could be the same length, but if I drew this triangle a little differently and R was here and P was here and Q was here, just because these are the same length doesn't mean they have to be similar triangles. So we can't necessarily find the length or the angle measure or the lengths for this. So we're going to say no for part C. All right, and that brings us to number 7, the last problem here. So for number 7, let's see what the problem says. It says we have a rectangular box, so we're imagining like a 3D prism. It has a length of 18 inches, a width of 12 inches, and a height of 9 inches. What we're going to do is we're going to have to find the dimensions of a similar box, so they have to be proportional, have the same ratios that of all of these that are described. So for the beginning part, let's say we know the length of this rectangular box is going to be 18. That's the length. And we know the width is going to be 12. And we know the height is going to be 9 inches. Okay, I'm going to go ahead and copy and paste that to use that in each of these parts. So in part A, let's see what we got here. In part A, let's go ahead and use that. We know that the length of this box is going to be 6 inches. So I'm going to go ahead and write that over here. The length is going to be 6 inches. They're telling us that. And they're asking us to find the dimensions of the other ones for the width and the height. So the width and then the height. So how are we getting from this length to this length? That's going to be divided by 3. So if we divide by 3 here to keep the same ratio, then that would be 4 inches for the width. And if we went and used the same ratio, then we go ahead and divide by 3. Then this height for this other box would be 3 inches. Okay, so that's part A. For part B, we're going to go ahead and use these same measurements again of the original box, but this time they're telling us that the width is going to be 18 inches. So the width, I'm going to write that in the middle, the width is 18 inches. I'm going to put a box around it because that's the one they're giving us. And then so we're going to go ahead and find the length and then find the height. So getting from 12 to 18, that's times 1.5. That's the ratio. This is going to be times 1.5, and this is going to be times 1.5. And so 18 times 1.5, that's going to be 27 inches for the length here. And then 9 times 1.5 is going to be 13.5 inches for the height. Alrighty, last problem for 7C says the height is going to be 27 inches. So the original dimensions here are 18, 12, and 9, and we're given that the height is 27. So the height is 27. I'm going to put that right lined up with the height. And we need to find out the width and the length. And so let's see what the ratio is between these. It looks like to get from 9 to 27, that's times 3. So we're going to do the same thing for the width and for the length. So 18 times 3, I think that's 54 inches. And then 12 times 3, that's 36 inches. So all of these boxes would be similar to the original box that was 18 by 12 by 9. But for A, this one, the box was scaled down. So all the measurements were 3 times smaller. For part B, all the measurements were scaled up by a little bit. It was times 1.5. And for part C, they were much bigger. All the dimensions were 3 times bigger. So there you have these 7 practice problems on finding ratios applied to similarity in shapes for geometry. And hopefully you found this helpful. And as always, keep up the great work, and I'll see you in the next one.